Okay, here we go. Heading a couple weeks into finals week, and we are going to talk about word problems using elimination part 2. So now we're really talking about mixture and rate problems. So the first sample that we're going to do together is called a rate problem. And to do this, we use the rate times time equals distance formula. In our scenario here, we have Michael can row 15 kilometers upstream or against the current in 5 hours, but it only takes him 3 hours to row the same distance downstream or with the help of the current. Find the rate of Michael in still water and the rate of the current. How do we do this magical thing? Well, we want to be able to find Michael's rate and the rate of the water. So we're going to always represent the person, the bird, the plane, whatever, with X. And the rate of the current, whether it's air or water or electricity, doesn't much matter, is always Y. With the current means like with the help of the current. I live in Santa Cruz, so I'm really used to when you are paddling out to go surfing, you are against the current. It's harder. But when you surf in, it's with the help of the current, so you go much faster. So downstream is also with the current, and upstream is against it, like uphill versus downhill, right? With the help of is always a positive thing, and with the hindrance, it's always a negative thing. So here we go. We have rate times time equals distance, and we fill in what we know to solve for what we don't know. So we know that the rate of Michael going upstream versus downstream. So with the help of the current, so X plus Y, will always take less time, and we're going the same distance of 15 kilometers in this scenario. Now with the hindrance is always a subtraction. It's a negative thing, and it always takes longer for the same. Now if I have rate times time, then I have to distribute. I have to distribute the 3 to the X and the Y. And then I also distribute the 5 to the X and the Y. And now I have a lot of what we've already looked at. We have now written our system of equations, and we can solve this. I see that I already have a positive and a negative, if only they were the same value, which I know I can make them be the same value of 15 by multiplying the top by 5 and the bottom by 3. And I need to remember I multiply the whole equation. So 5 times 3x and 5 times 3y and 5 times 15. Then at the bottom equation, I multiply everything by 3. 15x minus 15y equals 45. And I can now add up my equations, and I have eliminated the y value. And I can simply solve for x very quickly. So now I know that the rate of Michael was 4 miles an hour, or kilometers an hour. And I substitute the value for x into any of the equations, but I chose to use the easiest one, the top one, to solve for y. When I do this and using my inverse operations, I get that y is 1, which makes sense because if Michael is 4 kilometers per hour and in 4 hours he would have done 16, right? He would have done 16. But in 3 hours, with the help of the current, it takes him 1 hour less, right? And with the hindrance, it's going to take him 1 hour more. So that's why we know that Michael is 4 kilometers per hour, and the rate of the still water, or the current, is 1 kilometer per hour. Okay, I'm going to have you guys pause the video here if you're working from home and try this group try. In class, we're going to be doing this group try together. All right, let's see how we did. Now we're talking about a bird flying 12 miles an hour aided by a tailwind of y, right? So the bird is x and the wind is y. And we can see here that with the help of the wind, it always takes less time. It only took 1 hour to go 12 miles. And with the hindrance against the wind, it took 3. Again, I can go ahead and distribute the time to the rate. And I simply multiply the top equation by 3 to eliminate the y values. And you should have gotten 8 for the speed of the bird. And we plug that back into the top equation. It's the easiest one. And we find that the wind is 4. Yep, 4 miles an hour. And I could check it just to see, does it make sense? Ah, it does. So I know I did it right. So the bird is 8 kilometers per hour and the wind is 4, which makes sense, right? Okay. Let's look at our next sample, which is a mixture problems. And mixture problems, we always write one equation about the total value and one about the total quantity. So here we have a store wants to make a 30-pound mixture of almonds and raisins that sells for $5 a pound. Almonds are normally separate, $7.50 per pound, and raisins are $2.50 per pound. How many pounds of almonds and raisins will be used for this 30-pound mixture, right? It says hint. Write an equation about the total value and about the total pounds. So we already know that we have almonds and raisins for a total of 30 pounds, right? The pounds one is easy. The quantity is super easy. But what was the value of the almonds, right? The value of the almonds were $7.50 per pound, and the value of the raisins were $2.50 per pound, right? But what's the total value of this 30-pound mixture? Well, they're selling it for $5 a pound, and they're making a 30-pound mixture. So $5 times 30 is $150. So I know that I want to get rid of my decimals, it just makes life easier. So I can have 750 almonds, 250 raisins, and I got to add a couple zeros to this 150, right? Because I'm simply just moving my decimal places out of the way. Does that make sense? Let me just remind you that this was the original amounts here, but we moved the decimal places out of the way in order to not have them, not deal with percentages, right? So now what do we want to eliminate, the almonds or the raisins? Well, I like to eliminate the smaller value, so I'm going to eliminate the raisins by multiplying the top equation by negative 250. And I leave the bottom equation the same. I didn't do anything to it. This does eliminate the raisins. And now I can solve for how many pounds of almonds, which is 15. Well, we know that the pounds total were 30. So if it's 15 almonds, it obviously has to be, 15 raisins as well, right? That's kind of common sense. And I could check my work if I wanted to, but I'm not needing to. So this is a you try. It's a coffee one. You're going to do this with your groups. See how you do. If you're watching the video, go ahead and pause it and give it a whirl. Okay, in this scenario, we have coffee of $55 a pound mixed with coffee that's $15 a pound. And they're going to make a $25 per pound mixture for 75 pounds, right? Okay, so we got to label these coffees. $55 a pound, that's really expensive. So I'm going to call that my expensive coffee. And then I have this cheap coffee, which is $15 a pound. Honestly, they're both kind of pricey. But I'm going to say that the $55, that's really expensive. So I know that the total value is 75 pounds, right, at $25 per pound. And that is how I get the 1,875 total value. So now I know that X plus Y for a total amount of 75 pounds, right? Now the value of X is 55 and the value of Y is 15 for a total value of 1,875. Yep, now we have a system and we can finally eliminate. I'm going to do it the easy button and I'm going to multiply the top by -15. When I do that, I can eliminate the Y values. And I solve for the expensive coffee will be 18.75 pounds to make our 75 pound mix. And then the cheap coffee will obviously just be 75 minus that 1875 or 56.25. All right, you have some more problems to do. You get to it. Coming up this week, we also have the study guide. We'll have a practice test, and we will do that chapter test and move on to prepping for our final. Have a great day.